So let's talk about this. This now is going to be called the unit circle. And the reason why we call it the unit circle, I mean, you get why we call it the circle, right? It's a circle. The reason why we call it the unit circle is because we say it has a radius of 1. So if I take the radius of the circle all the way out here, right, and I bring it out to here, then this distance, this length in the x direction is just 1. So if I label this on my coordinates, this is just 1, 0, right? And then I can look in the y direction. And this coordinate up here, if I bring the radius, swing it up here, then that's just going to be 0, 1. And of course, if we continue to swing it around to this side, you have -1, 0. Bring it down to the bottom, you have 0, -1. And so it's really good to notice how these values change from positive to negative as you're going into different quadrants, right? Notice also I swung this way, which is counterclockwise. And if you ask me, that is counterintuitive. I remember when I first learned this, I was like, really? We're going to go backwards? Like, you're going to throw this whole thing on me and we're going to go backwards? But yes, we're going backwards. Backwards is the positive direction, and clockwise is considered the negative direction. And you can spin either way you want. It's totally fine. But if I say like I spin 180, well, 180 isn't a good example. If I spin 90 degrees in the positive direction, I am talking about being up here at this 90 degrees. Okay. Now you already know how to get around the circle in degrees, and that is what we've been working on thus far. Okay, so you know halfway around the circle, you did a 180. You know, if you go all the way around the circle, you're doing a 360, right? Or you could also call this 0 degrees. That's the same thing as saying 360 degrees, right? If I were to go backwards, -360 is also the same thing, right? Okay. -180 is also going to get you halfway around. Okay. And oh yeah, might as well fill in our 270. Okay, so you feel really good about degrees, right? But what about when we talk about radians? You're going to hear this word radians all the time. And what is a radian? Well, notice radian sounds just like radius, and that's basically what it is. I'm going to take this distance, and I actually made myself some pasta for lunch because pasta noodles work really well for this. I'm going to take this distance. This is the radius, and you can do this with a piece of string. I decided not to use string because I have yarn, and yarn like has this give when you're, pulling it side to side. So I just decided that I would do it with, take this radius here, save that just in case I ruin my radius thing. And this is the distance, right? So if I take this and I wrap it around my circumference, I can wrap it like this one time. It gets to like here. And then I'm going to wrap it. Well, I'll wrap it again in a second. Oh my gosh, this thing is like sticking to my paper. Okay, let's just talk about where it wrapped first, right? So if I make another ray here, because this is like from the center coming out here, a ray is just a line with a starting point and an arrow, right? If I make another ray here, this measurement, right, which we usually call something like theta. Before we're talking like in degrees, right? But now we're switching over to radians. This is actually just called 1 radian. It's a radian because I took the radius and I wrapped it around, and that's how far I went. So that is 1 radian. Notice I don't have to write a degree symbol. I don't have to put any units on the end. It's not like feet or anything like that. I just call it 1 because it's just 1 radian on the circle. Okay. So if I wrap this around again, I'm gonna do this again. And then, so this, if I make another ray that goes through here, this measurement would be like 2 radians. 2, and then I'm gonna wrap this one more time here. And it hits here. And oh my gosh. And oh my gosh, this noodle is like super sticky on my paper. This would be 3 radians. Ooh, my line's not perfectly straight. And yeah, notice that there's this itty bitty little space right here, right? So I have like 1 radian, 2 radians, 3. There's this itty bitty space. Well, what is that space, right? Like, wouldn't it just be so nice if I could just take this radius and just like wrap it around half of the circle with exactly 3? It turns out that little space is pi. Whenever we're talking about circles, we always have pi involved. Ooh, I wish like the edible pie was always involved, but this is actually pi, right? So 180 degrees around the circle is actually 1 pi. And if you look back at the formula for circumference of a circle, it is 2 pi radius. That is the formula for the circumference, the distance around any circle given the radius, right? So if I make my circle larger, then my radius is also going to get larger. So this relationship is always true, no matter how large or small my circle is. Now, if you look, if I made my, because this circle is a unit circle, if I made my radius 1, right, then the circumference of the entire circle is 2 pi, because 2 pi times 1 is just 2 pi, right? So that's kind of cool. So I get halfway around the circle, it's just 1 pi. If I add another pi, then all the way around the circle, 360 degrees, is 2 pi. Okay, kind of crazy. We know what a radian is. A radian is just like the radius wrapped around the circle here. And we know that to get halfway around the circle is pi, and to get all the way around the circle is 2 pi. Let's look at how these pi's work with our degrees. All right, again, this distance is going to be a distance of 1 on my x-axis. And we know that 180 degrees equals pi. And we figured out that 360 degrees equals 2 pi. And remember, the circumference of a circle is 2 pi r. I feel like this is like really helpful with everything. If this is pi right here, if I swing my radius around to here, how would I find, what do you think 90 degrees is? If this far around is pi, what is half of that distance? Pause the video, say it out loud. 1/2 pi. We also call that pi over 2, right? We can count around the circle by 90 degrees if we want to. We could start here and we could go, okay, 90, and then this would be twice 90, and then this would be 3 times 90, and then you get 4 times 90, which would be 360, right? Now we're going to do that with pi, all right? So I'm going to count up here. This is 1 pi over 2. Then I go to the next one. This one would be 2 pi over 2. See how that's just pi, right? Then I could count down here. This is also known as 3 pi over 2, all right? And then we get back here. This is 4 pi over 2, which we would just simplify that and call it 2 pi. You're like, all right, but I still don't really see all the triangles in this, okay? So let me just cut this quarter of the unit circle in half. All right, and I swing my radius up to here. So this is still my radius of 1. Okay, that distance is 1, and actually I'm going to do this to denote distance. All right, so my radius is 1, and I swung that thing up. Since I cut, what I was trying to do was cut 90 in half. So what is half of 90? So this is denoting 45 degrees. All right, sounds good. I can just make that a triangle and boom, I have the most beautiful special triangle. There are a couple of special triangles, and those just happen to be extremely helpful on the unit circle. Now, I'm going to put this special triangle right down here for just a moment, just so that you can see and you remember what that is, right? Special triangle, this one is an isosceles triangle. So this 45-degree angle and this being a 90-degree angle, that means all the interior angles add up to 180. So that means this other angle has to be 45. So therefore, both of these two sides are also equal to each other. Notice I have this down here. If this distance is x, this is x distance. This other distance is the same thing. And then our hypotenuse is the square root of 2 times x. All right. So this is a very special triangle. Okay. So, but what is 45 degrees in radians, right? Well, all I did to find 45 is I just took half of 90, right? So we're going to do the same thing with pi over 2. I'm just going to cut pi over 2 in half. And do you see how, like, in this quadrant here, when I bring this line up, it just has like, there's half of that piece, and then here's the other half of this piece, right? So I'm just going to split pi over 2 in half. But what is pi over 2 divided by 2, right? What is that? How do I do that? Well, dividing by a number is the same thing as multiplying by its reciprocal. I want you to say that out loud. Dividing by the number is the same thing as multiplying by its reciprocal. Okay? And you know what? Just so it's like really obvious, right? I'm going to put this 2. Anything divided by 1 is still itself, right? So to find the reciprocal of this, I just put it over 1 and then I just boop, flipped it over. The reciprocal is that thing flipped over. So now that I've turned it into a multiplying of fractions, I can multiply fractions all day long. I am so good at multiplying fractions. Watch this. Oh my gosh. Oh my gosh. Like boom, multiply fractions all day long. So this 45 degrees, that is actually pi over 4, which is like amazing. How would I find the other relating angles to pi over 4, right? Well, I'm just like this thing, we could just transform it, right? We could flip it over the y-axis, reflect it over the y-axis, and we would get our next one. So here, I'm going to count this. This is 1 pi over 4. This is going to be 2 pi over 4. Do this. 2 pi over 4. Same thing as 1/2. Then this is going to be 3 pi over 4. 3 pi over 4. 4 pi over 4. Then 5 pi over 4. Then 6 pi over 4. Should be the same thing as 3/2. And then 7 pi over 4. And then if we go one more, we should get 8 pi over 4, which is the same thing as 2 pi. Okay? So this is kind of cool. Like, you don't even need to really like know all these other quadrants, as long as you know this first quadrant, you can get that. You can recreate all of the other ones. Now, this is really cool, actually. What happens when we apply our sine and cosine rules with these, right? Let's say I wanted to know how, like this side here, right? Or this side down here. Now that you have sine, cosine, tangent, you can find those sides. So let's just see what happens when I take the cosine of pi over 4. Now, it used to be you were taking the cosine of 45. Now you're going to start taking the cosine of pi over 4. And the cosine of pi over 4 is going to be the exact same thing as the cosine of 45 degrees. You can check that in your calculator. But now you're going to be able to switch your calculator from degrees to radians, because these are what equal each other. So the cosine of pi over 4, and I'm thinking, oh my gosh, I need my SOHCAHTOA. So we're in cosine. So cosine of my angle is adjacent over hypotenuse. All right. My adjacent side from where my angle is, right? My adjacent side is this side down here, this bottom side. This side represents how far over my point is in the x direction. So I'm going to use x for my adjacent side. And then here, my hypotenuse is up here. And we already know that the hypotenuse is a length of 1. So I'm just going to say x over 1. Well, that's pretty amazing. So anything divided by 1 is just itself, right? So cosine of whatever angle I'm at is going to give me how far I am in the x direction. All right, let's figure out how far that is. Now, I know from special triangles here that my hypotenuse is, if this length is x, then my hypotenuse is the square root of 2 times x. And I know that my hypotenuse on my triangle is just 1. So I'm going to take this equation and I am going to solve for x. So I'm going to say, okay, square root 2 times x equals 1. To get x by itself, I'm going to divide by the square root of 2. And x equals 1 over square root of 2. Now, that is the distance here, but mathematicians absolutely despise dividing by irrational numbers. Like, we can't stand it, okay? Maybe I shouldn't say we. I'm fine with it, but in general, when calculating things, to divide by irrational numbers is like a huge no-no. So we need to rationalize the denominator. And how do we do that? Well, I know that if I multiply two square roots, I know that the square roots undo each other. So if I multiply by 1, then I haven't changed anything, because 1 times all this stuff is still all this stuff. But here, the square root of 2 times the square root of 2 is the same thing as the square root of 2 times 2. And I know what the square root of 4 is all day long. The square root of 4 is just 2. And now I'm so good at multiplying fractions. Oh my gosh, straight across the top as well. 1 times the square root of 2 is just the square root of 2. And so we get x as being the square root of 2 over 2. And that is going to be our answer. So this x distance here is really equal to the square root of 2 over 2. So coming up here, this point here on the unit circle is a coordinate. It's x comma y, right? And we know that that has to be, both of these numbers have to be either greater than, they have to be between 0 and 1, and they can equal 0 and 1 as well, right? So this thing, notice this point here, it's gonna be less than 1, right? which the square root of 2 over 2 is less than 1. You can plug that into your calculator and double check. So my x value is the square root of 2 over 2. Which is like awesome. Now I want to find the y value. Okay, so from my uh, angle here, the opposite side is representative of how high up I'm going on the y-axis, right? It's my opposite. So I'm going to come over here and I'm going to use sine because I want to use that hypotenuse again. And sine has the opposite. So now I'm going to take the sine of pi over 4. And the sine is opposite over hypotenuse. And the opposite is my y value that I want. And remember, my hypotenuse is still just 1. So y over 1, anything divided by 1, that doesn't change anything. The sine of pi over 4 is just my height of my point. And let's figure out what the height of the point is. This is going to pop right out of this nice, beautiful special triangle here. Because both of these are 45 degrees, we know that both of these sides are the exact same distance. It's our beautiful isosceles triangle. So if this distance is square root of 2 over 2, then this distance is also going to be square root of 2 over 2. And our y distance in our y direction is going to equal where we are in our x direction. And that makes sense on our unit circle because this point is exactly halfway between these 2 points, right? So this length better be the same as that length as well. So my y value is also equal to the square root of 2 over 2, and I'm going to plug that in here. So now we have done 45 degrees, and we have found our x value and our y value at this point, which is like it's so awesome that we can calculate this. Now, if I do the same thing over here and I come over here with this triangle, now that you know what the sine of 45 degrees is or the sine of pi over 4, right, that because they're equal, now you can probably figure out exactly how far I've gone to get to this point as well in the x direction and in the y direction. Notice it's going to be the exact same distance. This is the exact same distance, but in which direction, right? This is going to be the negative direction on the x-axis. So my y value is still positive, but now this is going to be negative square root 2 over 2 and positive square root 2 over 2 at this point. So my x comma y is negative square root 2 over 2, positive square root 2 over 2. Likewise, if I drop this line down here, oh man, my drawing's not perfect. Okay, that's supposed to match up. This is a 90-degree angle. But likewise, if I keep spinning and I come down here to 5 pi over 4, now where am I as far as positive and negative goes, right? Now I'm both negative in the x direction and negative in the y direction. So the coordinates at this point are going to be negative root 2 over 2, negative root 2 over 2. And now I'm going to do this last one over here. All right. Whoa. So now this one, now I'm positive again in the x direction, but negative in the y direction. So for all of these, for any degree that you want to look at, right, or any amount of radians that you want to look at around this unit circle, your coordinates should always be positive and positive in the first quadrant, right? They should be negative and positive in the second quadrant, and then they should be negative and negative in the third quadrant. And then over here, they should be positive and negative, right? For my X and Y values, okay? I'm going to make another video, and in the next video, we'll do the other special triangle and look at more degrees to radians. But I want to make one quick note, all right? You come around here, and we did here, we got to 2 pi. We counted by pi over 4, right? And so we got 8 pi over 4. You can go around as many times as you want. This is also known as 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4. And you can always check 12 pi over 4, right? How many times does 4 go into 12? And it should make sense that this is 3 pi. You've done one rotation around the circle, which is 2 pi, and then another half, right? So then you get to 1 more pi, right? So 12 pi over 4 is really going around the circle 1.5 times. And you can continue to go around the circle as many times as you want. You can also go in the negative direction, right? So let's just say that I go negative 12 pi over 4. That means that I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the negative direction, but I'm still going to end up right back here because I still went around 1.5 times. Okay.